try to look at the animation of the active transport. So we have an energy supply to the carrier, and this one are the examples of the particles that are being carried out inside the cells. Okay, so that is active transport wherein energy is being supplied in the form of ATP. Okay, so active transport, it is a movement of substance against the concentration gradient. When you say concentration gradient, that is the solute or against the solute. Usually the movement of the active transport is coming from outside to inside of the cells. So there is what we call higher concentration ingredient inside the cells because of the presence of different organelles. So from low to high concentrations, it is endergomic process wherein the energy is being it's being absorbed. In most cases, it's coupled by hydrolysis of phosphorus of the ATP. So two active transport. We have the primary active and the secondary active transport mechanism. Okay. So primary active transport. So primary active transport, also called direct active transport, directly uses energy. So yung mga primary, usually ATP is directly supplied in the carrier or the protein. Okay. So we have the site for the example, the movement of the sodium ion. So usually cytoplasmic sodium ions binds to the sodium potassium pump, this one, and you can, as far as you can see, there is what you call a low amount of sodium and even the higher amount of potassium. Okay, and inside there is higher amount of sodium and there is low amount of potassium. Number 2, sodium binding stimulates the phosphorylation process. Okay, so ATP is converted to ADP or adenosine triphosphate to adenosine diphosphate. So one phosphate group is being utilized during the binding of sodium, and phosphorylation causes the protein to change its conformations or shape or opening of the channel, expelling sodium to the outside coming from intracellular environment of the cells. And number 4, the extracellular potassium binds to the protein, triggering release of the phosphate group. So after na release ang sodium, it is the time that potassium will going to bind with the protein, and it will release now the phosphate group that is being used up. Okay. And number 5, loss of phosphate group restores the protein original conformation. So kung ma-release na yung phosphate group, kasi there is no energy, it will restore, and there is potassium is released and sodium sites are recepted again, and the cycle repeats. So usually this is considered to be a cycle. So after na release enter, I mean after the potassium enter, I mean, so sodium sites are receptive again. So kumbaga yung amount ng sodium, it will go back to the original state, then another cycle. So that is primary active transport. Okay. When you say secondary active transport, the secondary active transport or co-transport mechanism also uses energy to transport molecules across the cell membrane. However, in contrast to primary active transport, there is no direct coupling of ATP. Instead, the electrochemical potentials difference created by pumping ions out of the cell is considered to be instrumental. Okay, when you say instrumental, okay, it depends upon the movement of the sodium ion from that primary transport. So we have antiport system and symport. When you say antiport system, the movement of two ions are in opposite direction. Nahamakan man symport system, the movement of two molecules, and we have the glucose here, are at the opposite, are at the same direction. So when you say primary, first there is an exchange of your sodium and potassium based on the diagram I explained a while ago. So there's a supplement of ATP, and then sodium from outside environment of the cells will bind or guide glucose to enter the cytoplasm. So the take note that the movement of glucose from outside to inside the cells is sodium dependent. That is Simport process, meaning both sodium and glucose have the same direction. So this is antiport. Antiport, the two molecules or the movement of two molecules are opposite to each other. Okay, so two forms of active transports will be antiport. While ago I discussed. So antiport to two species of ions or solutes pumped in opposite directions across cell membrane. So Titus 1 we have sodium exchanger or even sodium and calcium exchange. So this is considered to be antiport system. So one of these species is considered to be high to low concentration, yielded entropic energy. Okay, there is what we call a entropy. Okay, or the energy is not being used up, and die to transport other solute from low concentration to region high concentration. So example, sodium calcium exchanger or antiporter, which allows 3 sodium ion to enter and 1 calcium to exit. Okay, or the exit is known to be efflux system. Okay.